Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. In today's episode, we'll discuss tangent lines and rates of change. Let's recall from our calculus preview session that we considered the function y equals x squared, in particular from the point 1, 1 up to 2, 4, as well as from 1, 1 to general locations on the curve x, x squared. The slope from 1, 1 to 2, 4 is the change in y divided by the change in x. So we get 4 minus 1 divided by 2 minus 1, which is equal to 3. We then found that the average slope from x equal 1 to a general location x, x, x squared, becomes y at the x value minus y at x equal 1 divided by x minus 1. We plugged in, did some cancellation, and found that the average slope, the slope of the secant line from 1, 1 to any point x, x squared on the curve, is given by x plus 1. Then we let our point on the curve move down toward 1, 1. As we do that, the x value is getting closer and closer to 1, and so the slope of our secant line is getting closer and closer to 1 plus 1, or 2. So the slope of a secant line, which gives the average rate of change along a curve from a, f of a to x, f of x, is given by the change in the y values, f of x minus f of a, over x minus a. As we let x approach a, we'd get 0 over 0, and this secant line becomes a tangent line, which represents the instantaneous rate of change along the curve at that point, at a, at x equal a. And we denote that by m, and that's defined to be the limit as x goes to a of the slope of the secant line, f of x minus f of a over x minus a. Let's do another example very similar to the one before. Here we take y equals x squared minus 1 from the Harvey Mudd College website, which has a very nice tutorial about tangent lines. And we consider the point P is 1, 0, and the point Q is just about x equals 2. So the y value is approximately 2 squared minus 1, or roughly 3. In this case 2.91. So we see the secant line given in red, the curve itself given in green, and the equation of the secant line found by the change in y over change in x giving the slope, and plugging in one of the points to get the y-intercept. It's given by y is 2.97x minus 2.96. As we let q get closer to p, now we have, instead of q being around 2, q is 1.3. We find that the slope of the secant line went from approximately 3 to approximately 2.3. And then we can further move down the curve to the point where p is equal to q. Both of them are at 1, 0. And we find that the equation of the tangent line is y equals 2x minus 2. In other words, the slope of the secant line has gone from approximately 3, then to 2.3, and as it becomes a tangent, we get the slope is equal to 2. This website also has a very nice facility that allows you to move the point on the curve at which you see the tangent line. So here's the tangent line that we saw in the previous figure through 1, 0. If we let x equals a half, we find the tangent line now has slope equal to 1. And if we further move the point down to the point where x equals 0, y is negative 1, we find the slope is equal to 0. The slope of the tangent line, which represents the instantaneous slope along the curve, is now 0. Okay, we can take this representation, which is sometimes a little more difficult to work with, and by making some substitutions, make it more usable. So we have our definition. The slope, or the slope of the tangent line, is equal to the limit as x goes to a of f of x minus f of a over x minus a. And let's turn all the x's into x plus h, all the a's into x's, and let's see what happens. The x in the limit becomes x plus h. The a in the limit becomes x. So our limit as x goes to a becomes the limit as x plus h goes to x. The numerator becomes f of x plus h, as x changes into x plus h, minus f of a becomes f of x. And the denominator, x, becomes x plus h, and a becomes x. So the denominator becomes x plus h minus x. Simplifying, We subtract x from both sides in this limit, so we get h goes to 0. The limit as h goes to 0 is f of x plus h minus f of x over h. And this is a form that's easy to use if we want to find the instantaneous slope along a curve f of x, where that function of x is given. We would often plug it into this bottom form. One could use the top form. Often we use this bottom form. Let's just take a moment for math culture. The dean of engineering once walked into the classroom and said good morning. The whole class responded, good morning. Hi, you're a class of freshmen, aren't you? The dean responded. One student, a little bolder than the others, asked, how'd you know that? All we said was good morning. Well, said the dean, when I say good morning to a class, if they're a class of freshmen, they say good morning too. If they're a class of sophomores, they quietly fold up their newspapers and they start to look at me and pay attention. A class of juniors will look at me over the top of their newspapers and then get back to reading the newspaper. A class of seniors will ignore my greeting altogether and just keep on reading their newspapers. When I say good morning to a class of graduate students, they write it down. Thank you for joining us today. Have a great day, and may the power of math be with you.